So have you ever wondered how complex integration systems work? Maybe you've heard about decoupling your application components, or maybe you've heard about the fact that you need to have many subscribers to certain events, for example. Well, today I'm going to be joined by Eastbury once again as we talk about 3 patterns today, all focused around messaging. Stay tuned to find out more. Hello there, and welcome back to another episode of Cloud with Chris. You're with me, Chris Reddington, and here we talk about all things cloud. Now, thanks once again for joining. We have another of our Architecting the Cloud One Pattern at a Time series episodes, and this time we are focusing all around messaging. We have a very packed session today because we're going to be talking about 3 different topics, and I'm once again joined by a colleague, good friend. You've seen him on the show already, and that is Eastbury. So Will, hello, thank you for coming back.
Hello there.
So 3 patterns we're going to talk about today, all focused around messaging. We've got a busy session.
We have indeed. Luckily, they're all related.
Absolutely.
Right?
So I guess the 3 that we're going to be talking about are going to be the pub sub pattern or publish subscriber pattern, priority queue, and pipes and filters. Maybe in that order. We'll see how we go. But those are the 3 that we'll be talking about today. So where do we start, I guess, Will? Where do you think is the best place to go?Maybe pub sub to start with?
Yeah, let's go into pub sub because it kind of tails through where some of the other sessions have finished off as well around, and cloud and queue load leveling and those other competing consumers patterns. So I guess where do you go after those?
Yeah.
So let's pick pub sub first. So the publisher subscriber pattern, which is really about changing from point-to-point messaging, where we have one system that is sending a command or an event kind of type message to another system with the expectation it's going to process it on its own, into a kind of multicast or broadcast type solution where we have a single message producer, but we have many consumers of the same message.
Okay.
As opposed to a queue, which is, of course, one-to-one.
Yep.
So the most kind of simplistic implementation, or the most common implementation of that in Azure, is a service bus topic, where you would see a topic will have a single set of producers. You can have many things sending to a topic, but you would almost always have multiple subscribers and subscriptions to that topic.
Gotcha. I guess the scenario, because you know how much I like analogies. As an example, I'm thinking of something like maybe a user signing up to a service, for example. It might be they need to have some kind of credit check done in the background. You need to go and create their account. You need to go and fire off to a number of different services, for example. That could be a good use case, for example. That event or that message, that trigger, for example, has come in, and then you've got a number of listeners that then start reacting to that particular scenario, I'm guessing.
Exactly, yeah. So if you've got either multiple parts of the same process, which of course we'll come to later, but multiple parts of the same process that you maybe want to disconnect and process in parallel, you could have multiple things listening to different subscriptions against the same topic, and then let's say you've got a system, system A producing in your publisher, and then systems B, C, and D, which are consuming and have their own subscriptions. And effectively then the work for B, C, and D can be done in parallel. Yeah, by the trigger of a single message. And that works really well if there's no dependencies between those subscribers, if they're completely isolated.
And it's quite nice in the fact that it decouples them as well, I guess, again, on that fact that if they have no dependencies between them, you have almost got this parallelism that you're starting to introduce in the system. So from a scalability perspective as well, and that perspective and making sure that you're not bottlenecking on one particular part or one particular component, it could be a nice benefit of that approach there.
Yeah, it becomes super useful where either the timing of the message is not important. So in a loosely coupled event-driven system, that you may want to have multiple consumers reading. I mentioned service bus, but there's no reason why this has to be purely like an ESB or enterprise service bus type scenario. This could be publisher subscriber to an event subsystem using something like Event Grid, where I've got an object appears in a system somewhere, or a blob appears, or something happens that I've got multiple subsystems that need to react to, and they have subscriptions, and the platform carries that event to you. So you use the example of a credit check, and that's not a bad call, right? So let's suppose you're a bank and you're going to give somebody a bank loan or a credit card sign up. And in that back-end system, you don't just want to check from one credit reference agency or credit service. You want to check for multiple ones, and they all have different characteristics and different instances. So you might choose to say, pop a message on that says do credit check or requires credit check, and that'll fire off to multiple services in the background that will then collate that data and get the data back to you somehow. But it's used as a trigger of a requirement there. One area we do see this pattern used a lot is where there is aggregation of lots of services. So it's a great example, and we see a few of these, are insurance aggregators. So, I've got a company that actually takes quotes from 15 or 30 or 50 other insurance services, and they all need to go and quote at the same time. So you might have back-end services which are listening to those. You paste one message saying, I need some quotes, please. And all of those back-end subsystems that are listening fire up and go and start to pull and aggregate those quotes and stream stuff back into a central system.
And I think if we look at maybe almost the anti-pattern way of doing it, just calling each of those different downstream systems directly, there are obvious challenges with that, right? The fact that you've got that tight cohesion, that tight coupling between those different services. What happens if one of them goes down, or you can't sequentially go through them all? Having this decoupling method and having this asynchronous way of doing it adds that resilience factor as well. I think is something we shouldn't forget about, just as a reminder for anyone listening in.
Precisely. Makes them pluggable as well.
Absolutely.
So you can just plug in new instances of your backend. So you've got a new insurance company or a new credit reference company that comes into play, and you want to light those up as well. All you need is another subscription to the topic and another listener.
Gotcha. No, I think that makes sense. I think the the scenario makes sense there. Maybe let's move on a little bit in our usual flow here, thinking about some of the challenges that might start arising if we start using this pattern. So on the face of it, it sounds, I should go ahead and use that. It's got lots of benefits there. But what might be some of the things I start running into or start getting challenges, I guess, around?
Your first key is it's one way. Yeah, so if you need to send messages back, it's amazing and simple for fire and forget messages. Yeah, put this over there and I'm done. Yeah. Log this.
Yep.
Do X. Yeah, it's brilliant if you want those done multiple times. And maybe an example of that is like a replication engine or something like that. Yeah, I need this replicated in 4 different places. Go put it there. Bang, 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 and they're all listening. But where you have something that requires a response, and in particular a synchronous response, so you need to know that the account was created or that the credit check was passed or score was high enough in real time to make a decision, that becomes more complex because you're not holding open the channel to all of those consumers and you're not having control over when they're actually going to respond.
And that's, I think, I can't remember if we've already spoken about it on this channel and recorded it, but definitely you and I have spoken about it anyway. The asynchronous request reply pattern comes to mind there as a way to solve that. So I guess not necessarily a challenge which is unsolvable, but again, it's just knowing that there's that kind of limitation in place and how you then need to go and deal with that, I guess.
Yeah, there's a spin-off to it as well, where you've got coordination of activity. So if you have a chain of processes where one triggers when you've got all of your quotes in, for example. So when I get 50 quotes in, am I complete? Do I only want 50? Yep. Or what happens to the 51st? What happens to that? So understanding, and there's a side pattern called choreography, which is a nice way of dealing with this as well. But understanding what you do while requests are in flight and when a request is finished, which is really, really clear if you're doing a synchronous call, right? It's finished when it's finished. and because you've got a response. But in loosely coupled cohesive systems, it can be quite complex to figure out if something is complete and what the response actually is, because there might be other services that aren't complete.
Yeah, no, sure. No, that makes sense. And I guess there are then some challenges as well. If we maybe go back to the insurance example, maybe let's stick with finance more broadly. If we're like a stock or a trading system, for example, the ordering of messages is super, super important there, right? Knowing, trade 572, 573, 574 come in that order, because it might be selling, it might be buying, and obviously it affects the overall price of those shares then. That's something that would potentially be a challenge with this approach, because I guess where you then start almost fanning out across those different components, there's not necessarily that guarantee then, is there?
No, and you typically would use this kind of approach in solutions where you don't want that uber hard guarantee. So you'll hear us talk a lot in the design patterns documentation around idempotency, especially when we're talking about messaging. So if I have a message that can't be played out of order, it's probably not the most amazing candidate for this pattern. Because by definition, we've got multiple consumers. It probably is going to get consumed out of order, even if you don't send it out of order.
Exactly. Yeah. No, makes sense. And I guess there's things as well, maybe just glancing through the doc here, that are issues or considerations, but again can be resolved. Things like thinking about back to our analogy of having these different subscribers, and maybe I care about user sign up as a notification. I don't care about that they've I don't care that they have taken out a new mortgage or a new loan or something like that. I just care about that initial sign up for some reason, and maybe that's the account creation subservice. Being able to filter out those messages is, again, something that you need to go and do, right? Because by default, I guess the pattern in its purest form, right? The pattern takes every single message, comes along, and then you do something with those messages. You might need to filter them out or do something with those based upon your domain.
Yeah, so there's two aspects of that, I guess. There's when you can have a filtered subscription is a concept in the platform backends. So both Event Grid and Service Bus Topics will allow you to do this. So you can say, okay, all of the messages are being arrived, but as a consumer, are arriving at my door, but as a consumer, I only want to accept certain ones. Yes, so the analogy there is that you receive a message on every single piece of spam you've ever seen, but you only choose to actually interpret and read some of those messages, and you might have an auto filter set up to just bin them, where you don't, and they will never be delivered through your door or into your inbox. They get action before they arrive there.
Gotcha. Makes sense.
The other piece around idempotency as well, and the example you just gave, I'd like to return to because it's a nice segue into the next pattern, is that idea around ordering. If you have a message that needs to handle a sign up of a subscriber to create a subscriber account, for example, before you can grant somebody a loan or do a credit check, because the secondary call will fail because it's dependent on the first one. Then we have a pattern which is priority queue.
There we go.
Indeed. And the key to that is obviously where you've got various parts of an application, usually in a distributed application, but it can actually be in a microservices or monolithic application, where some bits of your application need to respond more quickly and respond with different guarantees to the other parts over here. So if I send something to service A, it needs to be processed in 100 milliseconds. If I send something to service B, it needs to be processed within 1 second. And maybe service C, it could be processed tomorrow. But what's really important is the guarantee that at some point it actually will get processed. Gotcha. Yeah, and you can see those are three very different classes of latency and determination of message. So what you don't typically do in this kind of system is slap them all in the same queue. Yeah, unless you've got some way of prioritizing them, which is actually what the image is showing effectively on here. So there's some messaging systems, not all, some will allow you to attach a priority to a message, and it will deliver those messages first. What's much more common to do in practice, though, is to have a separate series of queues, hence the term priority queue. And if we scroll down there, Chris, a little,
There we go.
then you see a pattern that looks like this. Yeah, and what this is doing here, we've got 3 messages, message 1, message 2, message 3, going to system A, system B, system C. Yeah, and it's the queue attachment that gives it the priority.
Gotcha.
Yeah, so, and if you look here, what we've got, if you remember when we talked in the past about competing consumers patterns, what we've got is 3 separate pools of consumers all competing for messages from each queue. Sure. And they might have separate amounts of compute allocated to them. Yeah, so you might have an auto scale rule on the consumers that are doing compute for priority queue 1, yeah, which would have a higher threshold, so it can scale faster or it can scale out more. So priority 1 messages always get processed more quickly.
Gotcha.
Yeah, and priority 2 messages, look, you can see there's only 2 in the pool there. And for priority 3 messages, well, they just happen to get processed when they get processed. Gotcha. You might use low priority compute instances in Azure, like the spot instance types, to be able to actually process those when it's cheap.
Gotcha. And for anyone who's not watching the recording but listening in, the 2 diagrams that we're referring to there, imagine that you've got an application as a box, and then next to that you've got some messages going onto a queue. The first diagram we mentioned is, rather than having separate queues, you've got one queue, and each of those messages has some metadata effectively with a priority, and the queue is able to push those to the front as needed. Whereas the second one Will was explaining there is a little more around having the separate individual queues. So there's one which is a high priority, one which is a medium priority, and one which is a lower priority. And then you, as part of the application, send them to the different queues then as needed. So just in case for anyone who's listening in rather than watching the recording here. Now, it's interesting because I guess we've switched, from talking about topics and subscriptions there to talking more about queues, I guess. So is it typically a queue that we would see in this kind of pattern then?
Yeah, usually, but there's nothing to stop you from doing it as a topic. Yeah, if we, and for the benefit of the people on audio only, I'll do a voice description of this rather than referencing the pictures. So imagine a scenario where you have a motorway, and we want the depending on which country you're in, either the left or the right hand lane will be the fast lane. In the UK, certainly that's the right-hand lane. And stuff in the right-hand lane, people coming through there tend to require to be allowed through more quickly. And the expectation is that that traffic is prioritised over the top of other traffic coming through. So that's a nice analogy. Yeah? But there's nothing to say that all those messages are going to the same destination. So all those cars could be going to different places ultimately. And you could actually have a priority topic. There's no reason why you couldn't do that and have multiple subscribers consuming priority 1 messages. Yeah, and some of those again might get filtered, right? The analogy would be that you get to the end of the motorway or freeway or autobahn, depending on where you are, and whether you turn right or left when you come off at the junction or intersection will determine which consumer you actually get picked up by. The only thing is you can't turn right and left in my analogy. Yeah, for the same message. So the assumption here is you'd only have priority going to 1, but in topics you can obviously do that. The same car could arrive at 2 separate destinations.
Yeah. Gotcha. No, that makes sense. So I guess that addresses some of the challenges, at least, that we were talking about earlier. But I guess there's potentially some new challenges. I guess first off, before we even think about the challenges of the pattern, we need to have a good understanding of our system itself, right? We need to know what are those things that are going to be the priority versus the things which may not be the priority, and be able to determine which ones are the higher priority, because otherwise what's the point in even using this pattern, I guess. So that's number 1, is having that good insight into our system and the model.
Yeah, so the biggest probably concern I have when I see this pattern implemented this way is the idea of having lots of different pools of consumers checking for each pool. So it tends to raise the minimum level of compute that you're going to use. So you have to have certain instances. And because you're having a prioritization, you'd normally have a service level. So people start hard allocating compute to them. Yeah. So if you want a scenario, again, traffic flow, right, is a nice example where you have an automated service that's monitoring traffic flow and starts to implement restrictions on certain lanes if the traffic flow is too heavy, to try and slow it down. So it starts to throttle traffic on some of the non-priority lanes. If you've got that kind of platform, so if you've got throttling implemented on those endpoints, what you can actually do is use the same compute.
Yep.
I did think in the document there is an image somewhere, picture tells 1,000 words and all that, but I can't say it is actually further down. Okay, so for the benefit of those of you on the audio, what we're seeing here is an application posting messages. In fact, it's actually going to a topic. Go. Brilliant.
It was not planned
it's
at
actually going to a topic. Yeah, excellent. And we have a subscription for a priority flag. Yeah, so that flag is coming in saying we've got high priority messages coming in, and those are going to high priority consumers, and then lower ones are going to low priority consumers. Now, that's still split compute. Yeah, so they're not distinct processing pools. In this case, they're specific instances, and we're using the service bus topic to flip those messages, and you'd have to have filtered subscriptions. But there is another scenario, which I don't think we actually have an image of here, but where you can actually match priority queues to all consumers. So we have, instead of having a specialized pool of compute for consumers, there's a variant here where you can say, you have to be careful how you implement this, but I want to compute everything from the same pool, but I want to check 2 queues, and I want to check the priority one first. And only if that one is empty do I process messages for the secondary queue. And what that does, it effectively gives you it's almost like a queue-based implementation of quality of service, like you'd have on a network or a telephone line. Yeah, you process as much of the priority work as you can, because that's more important to you. And then when you've got spare compute cycles left over from that, you process the secondary work and the tertiary work. And then you scale out the compute capacity overall as a group. So if you add another instance, all of the workload gets the benefit from it, not just the high priority compute.
Gotcha. Oh, that makes sense. And I guess that solves maybe a challenge I was thinking of as we were talking about the priority queue a bit earlier, or at least the model, if we scroll up and then again just describing for everyone, if you had the 3 separate queue scenario, in that scenario there's nothing guaranteeing that you're not going to process priority 2 or priority 3, which may be lower compared to your priority 1 first. So if you did have some dependency between those messages, that's potentially a flaw in that design approach then. And that's maybe where, maybe thinking out loud, you might not depend on that initial message. You'd have to think about the flow of those messages then throughout the system, or what that journey is through the system. But I guess the scenario there you mentioned resolves that one.
Yeah, so you can see it's actually being described at the bottom of the screen at the moment in text, but without actually reading the scenario. But higher priority messages just must be received and processed first. Yeah. So you can do it in a couple of ways. You can drop a message and pop it back on the queue. So just terminate it if you're behind. Monitor the queue length of the priority queue, and if there are messages on it, blap messages back onto the secondary ones. But there's a whole ton of different variations, and which one of the variations you would use is highly dependent on the scenario that you're in and why you want to do this particular priority queue.
Gotcha.
I guess the key takeaway from the pattern is it's about prioritization under load. So it's generally better to be able to auto scale to meet demand and distribute compute across them. There's no guarantee that stuff is going to get processed first, even under this, as you just said. If my priority queue is under more load than my secondary queue is, and it's hit a limit of auto scaling, say I've maxed 30 instances in a particular set of on the app service, for example, is processing stuff off the back of these. And actually, at that point, my secondary queue might be sitting there idle. So it still won't guarantee it, and it depends on the semantics of your workload. But by and large, in workloads that will scale linearly, having a dedicated compute resource that scales out faster than the back-end resources or independently is generally a good thing.
Oh, gotcha. And I guess that's also where, thinking back to the previous pattern, pub sub, that's where we may start, once we've completed this priority queue scenario, we might go ahead and actually publish another message, which then the subscriptions are listening for, that, hey, the initial account is now created, and now you can go for that next phase of the messaging flow. Now you can go and run those credit checks or whatever they may be. I guess there's potentially a challenge there that if you try to depend on that single message, expecting the priority one to get processed first, and then that second queue is kind of holding up or whatever's happening there's a challenge. You might again get that scenario where actually there's this deadlock, this thing doesn't exist yet. So thinking through those kind of edge cases as well is probably worth doing, I guess.
Yeah, so, and things like retry and dead lettering. So, what happens if actually on my subscription it doesn't get delivered? What happens to the second message? Does it just keep going? Or the one that was dependent on the priority one? If that got dead lettered, is it going to keep retrying forever? Is it going to wait? What's actually going to happen in that scenario, and what edge cases do you have around that message delivery? That said, the idea of priority queue is to try and make things simpler in terms of how you can prioritize messages, not massively more complicated. Yeah. So if you've got that scenario where those messages are dependent on one another, it probably makes sense to process them sequentially rather than in parallel. Yeah. So message A is processed. Don't start process B until process A is complete. Yeah. And it's usually pretty easy to handle that in an application. So if there's a dependency on, let's say I have, let's keep with the same example, yeah? I sign up for my bank account or my credit card, and firstly, I need a consumer record to be created in your system, and that's the super priority record. Block until that's done, because it probably contains dependent information like a record of a user that's going to be created that all the secondary operations are dependent upon. Yeah, so priority queues is about making sure that gets done as quickly and efficiently as possible, not about handling the dependency chain behind it.
Nicely put. I think that's a good point for us to move on to the next one there then, which is pipes and filters. So I think, again, builds upon some of those concepts we've already talked about there.
It does, yeah. And there's a couple of things it's worth mentioning here, because this is a fairly open pattern. It's really interesting. I talk about this one quite a lot. So we've immediately hit upon this when somebody comes into our team with a challenge that says this is taking 7 hours to perform this process, and something is timing out or something else is happening. How do we make it reusable or break it down from this huge monolithic task into a subsequent set of items which can be processed independently? And the idea around this is literally the term pipe is obviously derived from the term pipeline. So if we use the analogy of water flow, let's say, I'm trying to fight for an analogy here, but when I turn on the tap in my house, the water doesn't materialize inside the nozzle of the tap or faucet if you're in the US. It has to come through a whole sequence of events and things and different pipelines to get to me. And some of those travel at different rates. So from a purification plant or a filtering plant, we come through a very big pipeline underground, and that might be carrying a lot of water, a lot of individual messages effectively, and some kind of transformation happens to it at each stage. So it might get metered before it moves into my house. It might be heated in a boiler before I turn on the hot water tap. And these different stages and different cycles are all different things that happen at separate stages of the water before I turn on my tap and it comes out. I guess we could continue with the analogy and pop a filter into it, actually. So if I have a water filter embedded in my tap or in my in my pipeline into the house, then not all of the things coming through that pipeline will necessarily arrive at my tap. Yeah, so some of the impurities will get filtered out, and that might mean that all of my messages coming through my pipeline in my analogy don't necessarily have to be processed by all of the stages.
Gotcha. So it's a nice way of then routing, isn't it, really, or kind of stopping at certain points what's getting through.
Absolutely, yeah. And if you think about that in the context of what we just said around PubSub, yeah, if you had a series of carriers of messages that flow between different services in a long chain, this doesn't really represent it like this in this particular diagram, but if we scroll down, there should be another one that gives us a more sequential flow diagram. Yeah, so we've got data in this case coming in from two components, and certain tasks need to be performed in the same order on the same to get to an outcome. Yeah, now we obviously talked a while ago around PubSub being the insurance company. Yeah, the insurance aggregator scenario where they trigger something, a load of different processes go off. And in this case, these are flowing sequentially. So what you might have is task A, go find your quotes. Task B, order and sort them. Task C, find out which one's the cheapest. Task B, present it on screen. And that's an internal, it's not really a cloud architecture, but that's an internal architecture of a service. So, but behind the scenes in the insurance engines that are generating the quotes, there's a whole ton of things which will be happening which are sequential. So go and take a look at the postcode for the area. Go and take a look at the insurance databases if this person's claim history matches up. Estimate the risk of this person. And then that will be happening in parallel across a ton of different quote engines, but sequentially inside the particular engine they've connected to. So these patterns kind of fit inside each other as well.
So it's taking that, it's almost building upon that asynchronous request reply pattern as well to a degree, isn't it? You're taking maybe not directly the reply piece, but definitely the requests, at least you're firing those off in parallel potentially, but then you're building that picture back up in a sequential way then throughout this pattern. Gotcha.
Yeah, it is. So the async ARR, async request reply pattern, tends to be implemented in a HTTP based way. So it's almost like, I don't know when this is going to finish, but the service might have an idea, so it can tell me when to come back and check. What we see sometimes where it's very complex, where there's lots and lots and lots of services all firing messages off at each other, is they might tend to aggregate their responses on a return queue, or possibly on a like service bus with sessions enabled, and each of the quotes or requests for quotes will have a return session where the return systems will fire back messages at that system, and then there will be an aggregator running which will just pull them all back into stream.
Sure.
Rather than necessarily looking at a blob. But either way is like perfectly normal in cloud. The important bit is you don't have a single process waiting and blocking whilst all of this crazy stuff happens in the background.
Yeah. And that's maybe a signal just to evaluate, isn't it, what you're doing now, if you've implemented that in a way that makes sense.
Yeah, exactly. And one of the things we see is where this is data focused. So I talk a lot, and we talk a lot about application architecture in the cloud and application design patterns.
Yes.
One of the areas where this is really useful, though, is data transformation. So the kind of thing in the past you would do with, SQL Server integration services, and you might now choose to do with Azure Data Factory in a batch process. But this can actually be done in a quite effective way in these pipelines. So they don't have to be messaging pipelines, which is we've talked about here, and the segue we gave in, might give that impression that it must be message focused. And certainly this document talks about it in a message centric way. But these are individual idempotent processes, right? Task A is dependent on task. Sorry, I'm looking at a different screen here. Could you scroll back up us for a second? And just for the benefit of our radio listeners, the diagram here, the top one, we will just take one leg of this. So we have a pipeline with an arrow saying data from source 1 coming in, and then we've got a pipe going through task A and a line to task B and an arrow to task C and an arrow to task D, and then an arrow outbound saying we've transformed our data, and it goes into some kind of logic, so we get an output. But these could be process pipelines. They could be something calling something else, calling something else, calling something else in process. A function calling a function, calling a function, calling a function. And the classic way you see this implemented with compute is something like durable functions. Yeah, with a series of activities chained together inside a longer running function, whereas that function then can run for a little bit of a longer time and it can restart if it fails. So you might use a message to trigger that activity. So the data from source one, big blue arrow in the top left that kicks it all off, might be a durable function. And then task A, B, C, and D might be decomposed into reusable ones. Equally, they might all just be posting back onto a topic, and they might just be different consumers for A, B, C, and D. Yeah. So this is a logical pipeline rather than necessarily a code pipeline.
Yeah, gotcha. It's the flow of the message through a certain part, isn't it? Yeah, gotcha.
Yeah, exactly. I mean, task D might be data factory. It could be a stored procedure in a SQL database, or it could be a logic app. And they don't have to take the same form, right? But the important bit is that when we bolt stuff together, use the right tool for the task that you've got.
Yeah. Exactly. Makes sense. And I guess the obvious maybe drawback of this is we're now in very kind of complex territory. So this isn't something you'd want to adopt necessarily if you've not got a real good use case for adopting this, right? Because this is going to add a lot of extra complexity into your design at this point.
Yeah. I mean, the pipes and filters one you use to abstract stuff away in general. I would argue you can use this to make stuff simpler and more comprehensible and understandable, but it absolutely can be abused. When you get any distributed environment that's running multiple processes in a disconnected manner, and they actually need to be recomposed afterwards, requires some kind of orchestration and something to oversee that task C hasn't stuck in an infinite loop somewhere, or there's some other scenario. So if you have got A plus B plus C plus D isn't sitting in the same app or the same process, or it's disconnected, this can get quite complex.
Yeah, trying to join that and glue all of that up together means that challenge is going to scale very, very quickly, isn't it? Of what you're working with.
Yeah, and it becomes exponential with the number of task steps,
yes.
Which would lead us into another pattern, which I don't know if you've already done, but it's called choreography.
I don't think we have done that yet, actually.
Yeah, that's a relatively new one, but it's how you figure out the state of something like this without having to flow it through every single step.
Makes sense. Makes sense. Cool. So I guess 3 different messaging focus patterns there that we've talked about. I guess, given now we've talked about each of those, Will, is there anything that maybe you wanted to kind of jump back to or talk about in the context of now that we know all 3 of those? Is there anything we should focus on in particular here?
I think maybe the related patterns it's worth touching on. So just allocating that we've done these. So we've done competing consumers. We know about that one. The idempotency patterns is something which is a whole new can of worms, to be honest, around the different things and what you would want to process more than once, or what happens when things fail. Have you done compute resource consolidation and compensating transaction in the series?
So I'm going to be doing compute resource consolidation, I think next week or the week after. And I think compensating transaction, I think, has been done, but I'd have to double check back. Yeah.
Okay, because those ones where you've got a process for in the architecture for pipes and filters, where you see those, so compute resource consolidation, where you've got multiple tasks running together, you don't put them all on their own compute, you cluster them. And compensating transaction is what happens if task A, B, and C are successful but D fails? Or if A, C, and D are successful but B fails? So in theory, in a pipes and filter pattern, if A is successful, B fails, then C and D should never run.
Should.
But how do you roll back A?
Yes. Yeah, indeed.
So that's a challenge that's answered again with another pattern. So it's worth mentioning that one at the end.
Nice. Good. And I guess, are there any other kind of top of mind thoughts when you think about the types of discussions that you normally have in this space? Is there anything that we haven't drawn upon at all during the discussion that's worth calling out? Any, I guess, closing thoughts as we start wrapping up really here?
No, I think messaging patterns within applications and within data pipelines are really important to understand. And the fact that each one that you come to introduces a new challenge and the next one builds on another. It's difficult to give a read until this, all of the patterns are done, the entire series is complete. But probably the most common one out of the three we've talked about today is PubSub. Yeah, without any shadow of a doubt, PubSub's probably the most common. It's one that people arrive at immediately after they do queuing. So it allows people then to start to branch out into the world of disconnected consumers and multicast events. So where it can really, really light up a big change in system architecture for people and application architecture to move to that broadcast event type, subscription type model.
And I think that's where,
and then all the others fall into place.
And I think that's where we typically see enterprise integration really start shining, isn't it? It's that kind of distributed compute world, but being able to subscribe to those messages effectively. And I think that's the key, as you say, the pub sub model there, which drives that.
Yeah, so there's an analogy around data flow and how it impacts application design. So the queuing is making it sequential, or attempting to make it sequential. Sure. Yeah, effectively, if you do it without competing consumers, you're trying to serialize the flow of information through a system and get it into a consistent order. Competing consumers is adding scale, multiple lanes to processing. And then PubSub is allowing branches in the road. So not everything arrives everywhere, but things can arrive in more than one place at once. So how do I get notifications of what's interesting to me as a subscriber into the hands of the right service? Priority queue is making sure it gets there before other things that shouldn't get there early. And then pipes and filters is, once it is there, how do I process it?
Excellent.
And actually trying to reduce complexity.
Excellent. Good. I think we've covered those three well and truly there. So thank you again for joining. I think another great session that we've talked through there, all of these messaging patterns. So, Will, thank you very much for joining today. Really appreciate it.
No problem. Thank you for having me.
Excellent. So we've talked there about the publish subscriber pattern, we've talked about the priority queue pattern, and we've talked about the pipes and filters pattern. Again, how they relate to some of the previous patterns we've talked about, like queue-based load leveling, competing consumers, and how you can go and build up and use all of those, again, as part of a kind of a messaging-based solution there. So again, we talk about these patterns. It's not necessarily a case that you should or have to use them, but make sure you evaluate some of the things that we've talked about, some of the scenarios where you may consider wanting to use them, and some of the trade-offs then, and the challenges that introduces, and whether that gives you benefit in your system. So, as always, you know what to do. If you've liked this episode, whether you're listening on Spotify, Apple Podcasts, Google Podcasts, please drop us a like. Please do share with your own followers. And if you're listening on YouTube and watching on YouTube, please like the video. Please hit subscribe and hit the notification bell as well, so you know as soon as we release new content there as well. And with that, thank you very much for listening in. This has been another episode in Architecting for the Cloud, one pattern at a time. And until next time, bye for now.